Okay, we're doing properties of circle. We'll start off with revising all the properties. Okay, the first property states the perpendicular bisector of a chord of a circle passes through the center of the circle, which is simply stating that if we have a circle and a chord and we draw a perpendicular bisector of this chord. Perpendicular bisector is perpendicular to the chord obviously, and it also bisects the chord in two equal parts. Then this property says that this line that we just have drawn, the perpendicular bisector of the chord, will definitely pass through the center of the circle. Okay, so the second property is chords that are equidistant from the center of the circle are equal in length, which is simply stating that we have a chord here and we see a chord here. If these two chords have equal distance from the center, which can be seen from these double lines, so these two lengths are equal, so then it would definitely mean that these two chords are also equal in length. So AB length will be equals to PQ length, since their distance from the center of the circle is also equal. The next property is that the tangent and the radius are always perpendicular to each other. So wherever you see a tangent in the figure and a radius along with it, mark a right angle with it. The next property is that the tangent from an external point are equal in length. So if we have a starting point indicated by P here and two tangents are formed from here and touch the circle, then these two tangents, these two orange lines are equal in length. Then it says the line from the center of the circle to an external point bisects the angle between the two tangents from the external point. Okay, so this is simply saying that this line here would now bisect these angles. So this angle and this angle, they'll be equal in length, and then similarly this angle and this angle, they will be equal in length. Bisect means that, let's say if this overall angle, let's say, was 120, then this blue line will cut it into two equal parts of 60 and 60. So in such questions, we already can apply the previous property, which was that tangent and the radius make a right angle, they're perpendicular. So there's a perpendicular angle over here, that's 90. One of these angles, the green one or the red one, it's given, and you can easily find the third angle. Okay, the next property is that the angle at the center is twice the angle at the circumference, which is simply means that we have an angle at the center, let's say this is 80 degrees. And then from the same starting points here, we have another angle at the circumference, let's say it's here. So this angle here would be half of the angle at the center, because the property says angle at the center is twice the angle at the circumference, which would make this 40 degrees. Similarly, you make any other angle on the circumference from the same starting points, you will get half of the angle at the center. This would be 40 as well. Okay, so another way this is asked in the past papers is that instead of asking for an angle here, instead of asking for this angle, the question actually asks for the angle over here. This is what needs to be found. So what you do now is you find this upper angle. So what would be this purple angle? This would be 360 minus 80, which is 280. And now angle at the center is twice the angle at the circumference, that property applies. So this would be double, this angle would be double of this angle. So to get your answer, you will do 280 divided by 2, which gives us 140 degrees. So we need to keep in mind that if we have a question like this, a circle like this, then this angle would be the double of this angle, right? This would be the double of this angle. And if we have a question like this, then this angle would be the double of this angle. So if the angle is pointing downwards, the other angle is also pointing downwards. Here if the angle is upwards, the other angle is also upwards. Next property is the angle is an angle is a semicircle. So this should be an angle in a semicircle is always 90 degrees. So another way of saying this out is that angle subtended from the diameter is always 90. If this is the diameter and we make an angle on the circumference from the corner points of this diameter, this would always be 90, which means this would be 90, which means this would be 90. So all angles subtended from the diameter equals 90 degree. The next property is simply angles in the same segment are equal, which means if we have a circle and we have an angle on the circumference of the circle, let's say this is 30 degrees, then any other angle subtended on the circumference from the same starting point would be 30 as well. So this would be 30, this would be 30, this would be 30, this would be 30. All these angles would be equals to 30 degrees. Then we have angles in the opposite segments are supplementary, or how I put it is angles in a opposite angles in a cyclic quadrilateral sum up to 180 degree, or like it says over here, angles in the opposite segment are supplementary, which simply means that this angle and this angle, if this is A and this is B, then A plus B would make supplementary angles, which means they would sum up to 180 degree. Similarly, if this is, let's say, C and D, then C plus D is equals to 180 degree. This is also called a cyclic quadrilateral. The cyclic quadrilateral is such a quadrilateral whose all four vertices touch the circumference of a circle. So in a cyclic quadrilateral, opposite angles, sum of opposite angles equals 180 degree. Okay, that's it with all the properties. Now we'll start with the past papers questions of paper 2 in the next video. See you there. But oh wait, this book does not address alternate segment theorem, so we need to discuss that as well. Alternate segment theorem.